This is homework set 19, multiplication and division of rational expressions. This question number 1, keep track of what I'm going to do here. I'm going to do a lot of cancellation. So I'm going to rewrite this problem first of all. We've got 20x squared over 5y squared. We're going to multiply that by 6y cubed over 4x to the fourth. Now I'm going to take care of these constants first. Now here's what I notice. I'm going to do some canceling as much as I can. 4 will go into 4 once. 4 will go into 20 5 times. Now this 5 up here, that will cancel with this 5 down here. Now we're leaving 1s. Every time you do a cancellation, you're left with a 1. Now what about x's and y's? Look on the top here. I've got 2 x's on the top, and down here I got 4 x's on the bottom. So these 2 here will cancel with 2 of these down here. And the y's? I got 2 y's on the bottom, 3 y's on the top. So these 2 y's on the bottom left will cancel with 2 of those on the top, leaving a y to the first. Now, we've got to pay attention to what we have left. We've got a lot of lines here that we have to make our way through. So here's what I see on the top. Up here I got a 1. These all cancel, so I just got 1 times. There's a 6 and a y. So I'll get a 1 times 6y on the top over, now on the bottom, a 1. These 2 canceled times that canceled. There's an x, but 2 x's, right? So I got an x squared. So on the bottom, there's a 1 times x squared. So I don't need those 1s. So how about 6y over x squared? And then what we're saying is this, up here at the top, this set of computing instructions, I've got 2 inputs. X's come in, Y's come in, and I do all this. Well, this can be replaced with this more efficient form right here. And in question 2, we've got a division. So the first thing I'm going to do is invert and multiply. I'll multiply by the reciprocal. So I'm going to rewrite the problem. 3x squared y over 7xy squared times, now take the reciprocal of this one, right? So take the reciprocal of that. So just flip it over, and I'll put the 14xy to the fourth on top, and the 6x cubed y squared on the bottom. Now, let's do our cancellation. So I like to look at the constants first. So what do I notice? Well, 3 will go into 6 twice. So let's do that. So 3 will go into 3 once. It'll go into 6 twice. And the 7 will go into 7 once. 7 will go into 14 2 times. Now let's take care of the x's. What have we got here? Well, in the very first term, I have 2 x's on the top, 1 on the bottom. All right, so I can cancel that 1 on the bottom like this. That 1 on the bottom will go with 1 of those. And then what about y's? Okay, y's. I got 1 up here, 2 down here. So this 1 up here is going to cancel with 1 of those. So I'm going to write this as that one is gone and that one is gone. So here's what I'm left with on the top. So just on the top, I've got this 1x and the y is gone. So I just get a 1x, or how about just an x? I get an x on the top, and on the bottom, I got a 1, that's gone. I get a y, so just a y, times. Now, over here in this factor, I can see, first of all, I've got those 2's, right? I've got that 2 is going to cancel with that 2. So let's do that one. Those 2's go out. And now what about the x's? I've got 1 here, 3 here. 1 on the top, 3 on the bottom. So that 1 on the top, this one here, will cancel with 1 of those, leaving 2. So be careful. It's hard to see through all those lines and little numbers. And then with y's, I got 4 on the top and 2 on the bottom. So these 2 on the bottom, those will cancel with 2 of those, leaving me 2. So what have I got left here? I have, okay, that's gone. Looks like just a y squared. So be careful, capture all of it. I got a y squared here. And on the bottom, what's left on the bottom here? That's gone. I got x, but there's a 2 here. Careful with all that notation. I got an x squared here, and the y's gone, so I got an x squared here. Well, and now what? Kind of much easier to see now. So this x here will cancel with one of those, and this y here will cancel with one of those. So what are we left with? I got one y on top, one x on the bottom. So how about if I just write y over x? And then what we're saying, of course, is that this set of computing instructions where you input an x and a y, and then you do all this work, instead of using this set of instructions, we can just use this set of instructions. So what comes in for y, what comes in for x, you just make that division. Much more efficient. Here in question 3, it looks like we can factor, right? These are factored already. Those are reduced to those terms. But look over here. Difference of 2 squares, and again, difference of 2 squares. Let's factor these. So we have a template for it, right? 2 sets of parentheses. In the top, unsquare. A and A, 7 and 7, make 1 plus, 1 minus. And in the bottom are 2 sets of parentheses. Unsquare, A and A. Unsquare that 4, we'll get a 2 and a 2. 1 plus, 1 minus, times. Okay, how about an A minus 2, A plus 7. And now I can see some common factors, right? A plus 7 appears as a multiplier up here and as a divisor down here. So let's cancel that inefficiency, right? Why would I do this? Why would I multiply something by a plus 7 and then divide it by a plus 7? Inefficient, so cancel that inefficiency. And I could do with the same with this a minus 7. No, I can't do that. Cancel that one. Well, now what I can see, though, is I can cancel these a minus 2's, right? I've got a multiplier up here and a divisor down here. So I multiply by a minus 2, then I divide by a minus 2. Inefficient, so cancel it. So here's what's left. What's left on the top is really a 1 times a minus 7 times 1. So what's left on the top is a minus 7. Over. Now what's left on the bottom? A plus 2 times 1 times 1. So there's an a plus 2 on the bottom. There we go. Now I'm going to do something else here. We're not asked to do this in the question, but I think it's a good idea. What values can you not use? I can't just use any old value of a. A cannot equal. Now look back to our factored form. What can you not put into the denominator? I can't put in a negative 2. I can't put in a positive 2. And I can't put in a negative 7. I can only cancel if I'm not dividing by 0. So what's going to make all these denominators 0? It's going to be negative 2, positive 2, negative 7. This just makes the answer more complete. Well, it looks like we've got a lot of factoring to do here, so I'm going to just start factoring here. So in the top left, difference of 2 squares, so I'm going to write this one as, here's our parentheses, I can write that as a plus 5, a minus 5, and the denominator, that's already reduced, so a minus 4 times, now let's factor these trinomials. So in the top, I'm going to get an A and an A. Now, what do you want to use? What 2 numbers do you want to use? When you multiply, you get a 12. But when you add or subtract, you get a 1. Well, what can you use for a 12? 12 and a 1, if I add or subtract, I can't get a 1 out of that. 6 and 2, I can't get a 1. But a 4 and a 3, 4 and a 3 is going to work. 4 and a 3. Now look, I can see kind of what's happening here. I had an a minus 4 down here. I know how these problems are written. They're written so that something's going to cancel. And I see an a minus 4, so I'm not surprised to see an a minus 4 here. So what about the signs? Let's get our signs right. The 12 is negative, so these have opposite signs. Now I'm going to go ahead and put that minus sign here and the plus sign here. Does it work? Just run a quick check. A squared. 3a minus 4a, sure enough, is minus a. We got it. And what about the denominator? We're going to have an a and an a. Now, what do you want to use for that 15? 15 and 1 or 5 and 3? Well, first of all, I can see I got some 5s up here, so I'm thinking I'm going to go with a 5 and the 3. Doesn't matter where you put them. 5 and a 3. Now, 15 is positive. They have the same sign, which is that middle plus sign. All right, so we've got everything factored. Now, let's look for common factors, and we'll cancel. Okay, I see an a plus 5 here and an a plus 5 here. Those will cancel. Actually, I'm left with a 1. What else? This a minus 4 will cancel with that a minus 4. And, oh, I see one more thing here. That a plus 3 at the top right, that'll go with that a plus 3. So maybe you can see that's left now. I think all that's left is this a minus 5. But if I was to write it all out, here's what I would see. I've got a 1 here, a 1 here, a 1 here, right? Because when you cancel, it's like this. It's like this down at the bottom right here. This a plus 5 will go into a plus 5 once and once up here, right? A plus 5 will go in here once, and it'll go in once up here. So there's really 1s there. So then what are you left with? 1 times a minus 5 times 1 times 1. So you're left with a minus 5. Then what are you left with in the bottom? Well, okay, there's a 1 here times 1 times 1, all right? Now, you don't need all those 1s, so you can see that all that's left is at a minus 5. And if I make this complete, which I always like to do, what numbers can you not really use here? A cannot equal, now just look back to your factored form. A cannot equal what? Let's just look at the denominators. What's going to make them 0? 4, negative 5, negative 3. So A cannot be 4, negative 5, and negative 3. Okay, that just makes the problem more complete. But the homework is asking us just for that part right there. Question 5, let's factor everything we can. So I'm going to take out of that top left, I'm going to factor out a 2, and what's left is y plus 4. And then a denominator, difference of 2 squares. So let's set that up in our template here. Unsquare, y and y, 2 and 2, 1's plus, 1's minus, times, let's see what we can do here. I'll get a y and a y. Now, 6, what do you want to use? 6 and 1? I can't get a 1 out of that if I add or subtract. But if I use a 3 and a 2, if I subtract, I can get a 1. All right, so let's use the 3 and the 2. So it's going to be a 3, let's get it to right here, a 3 and a 2, and the 6 is negative, so they have opposite signs, right? One's positive, one's negative, don't know which. Look at that sign right there. Put it with the bigger product. Inner product is 3y. Outer product, 2y. Put the minus with that bigger one. So the minus 3 plus 2, sure enough, is minus 1. And then I get the y plus 4. And now let's cancel. So what can we do here? This y plus 4 will cancel with that y plus 4. This y plus 2 will cancel with that y plus 2. And I think that's it, right? I don't see anything else. So what do we have left on the top? I got that 2 and the y minus 3. So how about 2 times y minus 3 over, now in the denominator, in that bottom, a y minus 2. Oh, that's it, just y minus 2. Okay, that's it. And then just to make it complete, which I like to do, look back to the denominators. What's going to make denominator 0? Negative 2, positive 2, negative 4. So I'm going to just say, to be complete, y cannot equal negative 2, positive 2, and negative 4.